So let's look at the application of the process we discussed to the following case study. So a research organization has developed a new carbon membrane that had structured pores of a size between 2 and 50 nanometers. And it's important why I mentioned this pore size. You will see it later. And successfully used this membrane for purification of industrial gases like oxygen, carbon dioxide, hydrogen, vapor of water, and so on. How did it work? Very simple. So the gas will go through the membrane, and impurities of a size bigger than 2 to 50 nanometers will stuck on the surface of a membrane. If you look at this membrane, it has a number of good features or parameters, but we will try to be more specific and define these technologies in terms of parameters and functions it's performed. Remember, the process that we discussed has 4 steps. And step number 1 is a discovery process. We will describe our technology in terms of parameters and functions. Why do we need this? Because in a later stage, when we'll start searching the universe of potential applications, we will focus this universe search through 2 lenses: lens of parameters that we are good at, and lens of functions that our technology performs. So what this technology is good at and where it's better than other technologies of purification of gases. There are a number of them, but when we benchmark our technology against others, we found the 3 main parameters where our technology is much better than any other gas purification technology. And these parameters are small footprint. Yeah, it's a small membrane that does a lot. Second, ability to function under high operating pressure. And the third is use of manufacturing and operation. So these 3 parameters we will be looking at will be identifying potential application of our technology. What function does our technology perform? By putting a simple functional model of the technology, we clearly see that technology performs 2 major functions. It stops and directs impurities and purified gases, and also it performs auxiliary function. It holds impurities. So these 3 functions, once again, we will use them as lenses in our search. So discovery process is over. Let's go for the search. Now, we could use Google or any other search engine, typed out description of our technology and see what we'll get. We'll probably get anywhere between 15 to 20,000 potential hits. But how do we know which of these potential applications or publications or patents are good for us? So we need to have a structured process that would allow us to get the smaller number of potential applications, but the ones where our functions and our parameters will be important. To do that, we will use the method using triad: subject, action, object. What did I do? My hand moves air. So hand is a subject, moves is an action, air is an object. I could find new applications for the hand moving air. I could find a new target when I say hand moves, and hand moves chair, hand moves water or something else. Or I could find new functionality. What else can my hand do? The same with our membrane. Remember, from our functional model, we know that membrane directs gas. or membrane stops impurities. So we will be looking for new application of a membrane that directs gas or membrane that stops impurities. We will be looking for new targets, membrane stops or directs, or we will be looking for new application. What else our membrane can do? So this will be the focus of our search. Where will we look? We will look through the US patent base. First of all, why we're looking at US patent base? Because it's a well-structured set of documents that easy to search, but more importantly, it's because people patented certain technologies because they felt that applications of this technology, application of these patents could create value in the marketplace. Our goal is to find the patents that perform similar functions that ours and then see if our technology could do better. So the goal of our search is not to find new patents and analyze them, but rather find applications where these patents were used and then see if our technology could do better. So let's do the search. Now, instead of 15,000 potential hits from the Google search, we'll get 230 patents that separate in 33 technology domains. Sounds like a lot, which is a good news because there are a lot of potential applications. But at the same time, it's a much narrow field that we need to analyze. So let's look at some of them. A patent that talks about using separation technology in pharmaceutical industry when they need to purify some peptides. We'll look at these patents, but we're not going to analyze the patents. Our goal is to see potential application. Another patent that talks about purification of exhaust gas from engines, pumps, and turbines. Once again, we're not going to analyze this patent, but we will see later on if our technology could perform a better job. So these two applications are direct new application of the membrane stops impurities and membranes direct gas. Let's look at the application when a membrane could stop something. We will look for new target for our technology. As you might remember, our membrane has pore sizes between 2 to 50 nanometers. Therefore, we need to look at different substances that have sizes smaller or bigger than 2 to 50 nanometers. The substances that are smaller could go through, as substances that are bigger will stuck on the surface. So we could direct or separate these substances out. There are new targets that could be used. There are sugars, lipids, or proteins. This is the area that developers of technology would never think about and never used it because their focus was of separation or purifying of industrial gases. Now we could go in areas like blood analysis or preparation of sugars in food industries. So these are the new targets of a technology. And now let's see if we could find new functionality for our membrane. What else our membrane can do? Once again, as a developer of technology, we know everything about technology, and we know that certain substances will stuck on the surface of a membrane. Can we do something with these substances? Yes, we can. There are technologies where surfaces of different membranes are coated with catalysts that promote some chemical reactions of substances that stuck on the surface. Can we do the same with our membrane? Once again, by using different taxonomy on search and using US patent base, we have identified areas where similar technology is being used. Now our goal to see if we could bring our technology and do better and make money on that. In order to do that, we need to compare possible applications. We need to look at three main parameters. One, how easy or difficult is to adopt our technology for new application. What value does our technology bring by bringing these new features, low footprint, easy to operation, and functionality under high pressure? And eventually, how big is the market? So by doing analysis of all these three parameters for potential application, we could further narrow the search and finally look at business case for our technologies, for us as developer of technology, for end users. For this case, we need to look what is the size of potential business and what kind of financial metrics we could use to analyze this business case. And secondly, how difficult for us using our capabilities and capacity to start producing this technology for new applications.